Hi everybody, and today on Saltash Maths and English Studies we're going to be covering the rules for indices or powers or exponents. So you'll be able to get these basic introductions and it will help you through your algebra. Enjoy! Hi everybody, and today we're going to be covering powers, indices, and for certain countries what you would refer to as exponents, but they're all the same thing. And I'm going to provide you with 7 rules to help you work out what these things do. So first is a quick recap of some technicalities that you need to know for the process of what we're about to do. First thing is 5 squared and x squared. The 5 and the x are referred to as the base, and the 2's here, both of them are referred to as the power. So writing that out in full, 5 squared would be 5 times 5 and x squared would be x times x. And there you go, just labelled up what those things are, and this is quite important. Okay, going into the first rule, which is the multiplication or the product rule. So if I had, for example, x squared times x squared, that would be x to the power of 4. What have I done? Well, all I've done is I've added the powers. Why is that? Well, because if I had x squared and I expanded it, and the second x squared in my example, then drop down the x that I left out from that expansion, I'd end up with x times x times x times x, which is x to the power of 4. More broadly speaking, as a general rule, x to the power of a times by x to the power of b gives me x to the power of a plus b. So here's some examples. X to the power of 5 times x to the power of 6 equals x to the power of 11, because 5 plus 6 is 11. X to the power of 2, 25 times squared, times 25 to the power of 16 gives me 25 to the power of 18. How about x to the power of 5 times y to the power of 6? What do you think the answer to that might be? Well, it doesn't work here because the product rule doesn't work because the bases are different. And for all of these rules, all of them, the bases must be the same. Okay, on to the second rule. Division, or the quotient rule. So if I have x to the power of 4 divided by x squared, or as I sometimes write it, x to the power of 4 over x to the power of 2, x squared, that equals x squared. What am I doing? Well, I'm subtracting the powers. Let's have a look at it in sort of an expanded form. If I write x to the power of 4 and x squared, as I've just done here, and then I cancel down x's in the numerator and the denominator, then I end up with x times x, which is x squared. In other words, what I do is x to the power of a divided by x to the power of b equals x to the power of a take away b. Now sometimes I write it like this because it makes me remember more easily which way round it goes. X to the power of a, the numerator power, subtracted by x to the power of b, the denominator power. The top power subtracts the denominator power. That's just an easy way of remembering it. Let's have some examples. X to the 16 divided by x to the 8. Okay, well it's 16 take away 8, so it's x to the power of 8. Y to the power of 100 divided by y to the power of 10. Well, that's 100 take away 10, so that's y to the power of 90. How about x to the power of 12 divided by y to the power of 6? Well, again, the division rule here does not work because the bases are different. And that's my second rule complete. Okay, into raising a power. What does this mean? Well, if you see something written like this, x squared with a bracket, with another power raised above the first power, which way I remember it's called a raised power, is x to the 12. What am I doing? All I do is I multiply the powers. 2 times 6 equals 12. The general rule is x to the power of a raised to the power of b equals x to the power of a times b. Here's another example then. 6 to the power of 2 raised to the power of 6 is 6 to the power of 12. y to the power of 3 raised to the power of 5, so it's 3 times 5, so it's going to be y to the power of 15. And that is my third rule. Now here's the one that nobody likes, but I'm telling you it's really, really easy. It's the fractional indices. Sounds awful, but it really isn't. Here's some, I'm just going to put some examples down and you can see if you can see a pattern. X to the power of half equals the square root of x. X to the power of a quarter equals the quarter root of x. X to the power of a third equals the third root of x. Can you see the pattern here? The pattern is easy. If I had x to the power of an nth, then whatever the denominator is, and here it's got n, is the root, so it's the nth root of x. Let's have some examples. X to the power of a half, well that's the square root of x. What am I saying? Y to the power of a half equals the square root of y. 8 to the power of a third is the third root or cube root of 8, and that's 2. And then if I have 32 to a fifth, that's the fifth root of 32. Well, that's 2 as well. Hope you got that. That's the fourth rule done. Into the fifth one. So the negative powers. Okay. And well, that's x to the minus 1 equals 1 over x. Now, what I do is I take my x minus 1 and I make it into a fraction, because anything divided by 1 is what it is. So x divided by 1 is still x. And I have this idea of inverting whatever my new fraction is. So I take whatever's in the numerator and make it the denominator, and whatever's in the denominator and make it the numerator. So I'd write 1 over x, and that's the way I remember how to do it. So here's some examples. Y to the minus 1 equals 1 over y. 12 to the minus 1 equals 1 over 12. And 5 to the minus 1 equals 1 over 5. I've just used that rule I did. I just thought of it as everything over 1, then inverted it as I did in this top example. The idea of inverting comes in handy, as I've done there, when I have something like a half. Well, what do? Well, I do exactly what the rule tells me to do. I invert it. I put the numerator in the denominator position and the denominator in the numerator position. I get 2 over 1 in this example. And of course 2 over 1 equals 2. How about 3 over 4 to the power of minus 1? Well, I invert it. That's 4 over 3. And how about 8 over 7 to the minus 1? Well, that's 7 over 8. Easy? It is easy. That's the fifth rule done. 2 more to go. How about when the power equals 0? Well, you're going to like this one. X to the power of 0 equals 1. In fact, 3,500,000 to the power of 0 equals 1. 212 to the power of 0 equals 1. Are you getting the rule here? Anything to the power of 0, it equals 1. That's the sixth rule, done and dusted. And then the final one that I'm going to show you today, which is the power of 1. So x to the power of 1 equals x. In fact, 12 to the power of 1 equals 12. 3 to the power of 1 equals 3, and a half to the power of 1 equals a half. So there you have it, 7 easy rules for indices, powers or exponents. If you've enjoyed the video, then please like and subscribe. See you later.